Hello dear students. So in last video lecture we have concluded our quantum numbers, different quantum numbers. So before going to the rules of making electronic configuration, that means wave mechanical model, how we construct atomic model, arranging the orbitals, we will first get familiar with these orbitals. Okay, that what are the different orbitals that we can have. Okay, what are basic features in these orbitals. So we will get familiar to those things. We will see one by one. Okay, that what type of orbitals and how they are generated actually. So suppose we have n equal to 1. Okay, suppose we have principal quantum number value n equal to 1, then obviously L can be 0 only. I have told you that the value of L can always the allowed values are n minus 1. Okay, that means you cannot have n equal to L. It's not possible. Okay, n equal to L, that means L is not equal to L. Okay, n and value and L value cannot be equal. L is always less than n. So only n minus 1 possible values are allowed. So for n equal to 1, the only possible value of L is 0. That means we cannot, since L is 0, it implies the orbital is S. So we are getting S orbital associated to quantum number value 1. So we will call it 1s orbital. 1s. We will call it 1s orbital. That means why 1s? Because the principal quantum number value n is 1 and L value is 0. So since L is 0, it will be s orbital. But the thing is, this 0 of L is connected to principal quantum number value 1. That's why 1s. Okay, it corresponds to first value of n. Now let me write it down. It will help us in understanding. So it gives us 1s. Now suppose we have n equal to 2. So the possible value is 0. 0 is still possible because we have 2 here. So we will get 2s orbital. See, 1s, when n was 1, L was 0, we got 1s orbital, and when n is 2, we again get a value 0, and this time it's 2s orbital. Okay, so 1 is also possible because since we have 2 over here, n equal to 2, that means, and it will be 2p because for L equal to 1 we have p orbital. Okay, then suppose we have n equal to 3, then what are the possible values? We have 0, we have 1, we have 2. Okay, I'm not going into the ml value right now because ml value is very easy. If I have L equal to 1, then ml will be minus 1, 0 plus 1, and every time it will be the same. So what I get, n is 3, L is 0 again, so I get 3s orbital. N is 3, L is 1, so I get 3p orbital. 3d orbital because L is 2, so it will be d orbital. Okay, similarly you can see for n equal to 4, you will get 4s, 4p, 4d and 4f orbital. So see, for each set of principal quantum number, we can have certain orbitals and subshells. Okay, different subshells will be there. So this is the basic idea behind orbitals, how they are formed, how they are generated, and what are the different kind of orbitals. Okay, so I hope you have got an idea about these orbitals. I have already told you that only 2 electrons you can place in a subshell. Now see, we already know that we can have all these orbitals we can have all these orbitals in an atom. All the orbitals are possible. Okay. So since all the orbitals are possible, then how we will know that to which orbital electron should go? That means suppose I have a hydrogen atom. Suppose I have a hydrogen. Hydrogen, the atomic number of hydrogen is 1. That means it has 1 electron. Okay, and I have 1s, 2s. I have seen already that I have 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, and so on. I have variety of orbitals. But in hydrogen, I have only 1 electron, and I have I have a choice of too many orbitals. So the question arises here is that where should I place this electron? In which orbital this electron will go? Okay, in which orbital it will go? Okay, so we have to set certain rules. We have to follow certain rules in constructing the atomic structure, atomic arrangement using these orbitals. Okay, so let's see those rules. Okay, the first rule is called Aufbau Rule. Aufbau Rule. And what is the meaning of Aufbau? Aufbau means, it's a German word which means building up. Building up. Okay, Aufbau is a German word which means building up. So what does this building up means? The building up means, see, when we start constructing a building, we start from the ground floor and we go to the top floor. Okay, and brick by brick, brick by brick, we join one brick, then next brick, then next brick, and this is how we go upwards. Okay, joining brick by brick. Is it possible that first we construct the 5th floor and then we will construct the ground floor? It's not possible. Okay, 5th floor cannot lie in empty space, in air. We need a foundation. We have to go in certain direction. Okay, in certain direction we will move to the upper floors while constructing a building. The Aufbau principle is the same. Okay, it says similar thing. It says it says that electrons are filled in an atom in increasing energy levels, that is electrons are first filled in orbital with lower energy. So electrons are first filled in orbital with lower energy. That means we have too many orbitals. So which orbital should we choose first? Which orbital should we choose second? And how these orbitals will be decided, that to which orbital an electron will go? So Aufbau rule exactly tells us what to do. And what it tells us that electron will be filled in firstly it will be filled in a orbital which has lower energy. Okay, suppose that means I have two boxes, I have two orbitals, two boxes, and suppose this energy is E1, this energy is E2. So suppose if E2 is greater than E1, that means if this energy is higher, then first electron will come here. Okay, first of all I will put the electron here, okay, in lower energy state, and if suppose this box is filled, I have placed 2 electrons, okay. So I have already reached the maximum capacity, because I have told you that I cannot place more than 2 electrons in a box. So if third electron comes, then it will go to E2. Till 2 electrons we will first fill E1, because it has less energy, lower energy. That means the electron will come to the lower energy state first, and then if the capacity of lower energy state is over, then it will go to the next energy state or next energy orbital, okay. And this is how the orbitals are filled, okay. So I hope this is easy to understand, that the orbital having lower energy will be filled first, and then higher energy orbitals will appear one after another. It's okay, but the prime thing is that how we will know which orbital is more energetic. How we know that which orbital has more energy, 1s or 5s? How we will know that this orbital has higher energy or this orbital has higher energy? Okay, to do that we have a rule, okay, we have a trick, you can say, to solve this problem, and that is called, there are 2 rules. First, if n plus L value of an orbital is higher than, it will have higher energy. Let's see one example. Suppose we have 2s and 2p orbital. Suppose we have 2s and 2p orbital, okay. So see, 2, that means n is 2. S means what? The value of L is 0. Here number is 2, that means n value is 2. P orbital, so L value is what? 1. So what is n plus L? The n plus L will be 2. What is n plus L here? In this case n plus L will be 3. So see that 2p orbital has a n plus L value 3 and 2s orbital has a n plus L value 2. So you can easily say that 2p orbital, energy of 2p orbital is greater than the energy of 2s orbital. 2p orbital will have more energy than 2s. This is what n plus L tells us, okay. Understand? Now we have one more rule. I hope you have understood this. In this way you can compare any 2 orbital. You have to just know what is the n and L value. So the numeric part is n, and depending on orbital, whether it is s, p or d, you can determine L value. S is 0, for s L is 0, for p L is 1, and for d L is 2, and so on. Now see, if 2 orbital have same n plus L value, then orbital having higher value of n will have higher energy. That means if n plus L value of 2 orbital is higher, then the one having higher value of n will have higher energy. Let's see an example again. So let's see 4s and 3p orbitals. So n value is what? 4, L value is what? 0, n value is 3, and since it's p orbital, so L value is 1. So So now see, n plus L value is 4 and n plus L value is 4. So see, we have same value for n plus L. Now how we will determine which one will have higher energy? So orbital having higher value of n will have higher energy. That means energy of 4s orbital is higher than energy of 3p orbital. This is how we decide. Okay, so these are basically the two rules in Aufbau by which we can decide which orbital will have higher energy and which will have lower energy. Okay, and once we know which one is higher, which one is lower, we can do what? We can place electron in increasing energy orbit. Now see, this is actually basically I am writing some energy diagram. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s. This is how orbitals will appear. After 1s we will get 2s, after 2s we will get 2p, after 2p 3s, 3s 3p, 3p 4s, 4s 3d, 3d 4p, 5s. This is the actually sequencing. The first orbital is 1s, then we will get 2s, 2p, and you can compare the energy levels. It is placed in the increasing order. Okay, so if you can remember this, it will do. You will be able to form the atomic orbitals, or you will be able to construct the atomic structure, the electronic configuration for any atom till atomic number 38. Okay, so now we will see two more rules. Okay, one is Pauli's exclusion principle. So what Pauli's exclusion principle say? It says that no two electron in an atom can have same set of all the 4 quantum numbers. Okay, see, we have discussed in the last video lecture that we have 4 quantum numbers, n, l, ml and ms. And what Pauli says that suppose an atom has 100 electrons. Suppose we have 100 electron in an atom, and if you randomly choose any 2 electron, you will never get same value of n, l, ml and ms for 2 electrons. You will never get same values. You will always get different quantum number values for all the electrons. So let's see one example how it happens. Suppose we have 2 electron, first electron and second electron. I have randomly chose this 2 electron from an atom, suppose arbitrary atom, and suppose the first electron, both the electrons are in 2px orbital. Suppose 2px orbital, because in p orbital we have 3 boxes. We have 3 boxes, px, py and pz. So suppose the 2 electrons are in this box, the px box, 2px. So see, we will get okay. So for first electron, 2p orbital, that means n is 2. L means it's p orbital, so L value will be 1. Now see, for p we have 3 ml, -1, 0, +1. Let's assign this -1 value for px, because one value will be given to x, one will be y and one will be z. So let's assume that -1 is for x, and say the first electron is in clockwise direction, so +half. Now see, for the second electron, it's in the same orbital, so n value is same, l value is same, px, so even ml value is also same. See, we should not get all the 4 quantum numbers same. Okay, the rule says that we will never get all the 4 quantum numbers same. Till now 3 quantum numbers have already been repeated, so 4th quantum number will be minus half. That means what it says that in a box, I have told you that 2 electrons are allowed, but you cannot place 2 electrons like this. This is not allowed. You have to place in such a way that the spin of one electron is opposite to the other. Okay, that is it. So this is what Pauli tells us. So Pauli tells us that what you have to do, you have to place the second electron in such a way that its spin is just opposite to the spin of the first electron. Okay, now see the last rule in this series, and that's called Hund's rule. Hund's rule of maximum multiplicity. So what Hund's rule tells us? So Hund's rule tells us that degenerated orbitals or subcells are first filled singly. I'll not write the statement. I'll just tell you. Suppose I have 3 electrons. And I need to place them in p orbital. Suppose I have p orbital. So I have 3 boxes and I have 3 electrons. I need to place them in these 3 boxes. So I have 2 choices. You'll see that to fill these boxes I have 2 choices. I can do this and I can do this. That means I can place 1 electron each in each box, and what I can do that I'll pair this box and then I will move to the next box. And this is what Hund's rule tells us. You cannot do this. You cannot do this. Before giving electrons to each subcell, you cannot pair a single subcell. Okay, so this is what is allowed. You have to first fill the subcells singly. You have to give 1 electron to each subcell, and only then you can start pairing this orbital. Now if the 4th electron comes, you can pair this, 5th, 6th, and so on. So this is how you pair a degenerated orbital. You cannot do this. You cannot pair that means the first electron you placed here, the second electron you place here only. It's not possible. If the first electron comes here, the second electron will go here, the third electron will go here, and if the 4th electron comes, then the pairing will start. Okay, so you have to keep in mind that electrons are first filled singly. Okay, and only after that we'll start pairing these orbitals. Okay, and we will see that why we do that. Okay, we will see the reason why Hund's rule is applicable, why the orbitals are first filled singly and then pairing is done. Okay, so this is all for this video lecture. We have studied 3 basic rules in construction that we will be needing while constructing the atomic orbitals. Okay, so go through these video lectures carefully. Okay, and hopefully in the next few video lectures we will conclude this chapter. We will be doing some exercise problems from NCERT textbook also. Okay, and then you will have your first assignment and as well as written notes. Okay, thank you.